Welcome to this module on extending application capabilities. In this video, we will discuss about managing approvals. Let's get started. In this lesson, you will learn how to create human task page process, and then you will understand unified task list. Furthermore, you will learn how to create a unified task list page and understand how to create human task programmatically. Let us see a demo on creating a human task process. Creating a human task create page process. To create a human task create page process, navigate to the page and select Processing tab. Under Processing tab, right-click on Processing and click Create Process. In the Property Editor, enter the following. For name, type Submit Expense Request in this example. For type, select Human Task Create. Under Settings section, for definition, select appropriate task definition. In this example, expense request. For details primary key item, select the primary key item. In this example, let us select P3_EMP number. For success message, enter appropriate text. Now you need to select parameters for submit expense request process. Under parameters in the left pane, for estimated cost, enter the following. For type, select item. For value, select P3 estimated cost. For expense status, enter the following. For type, select static value. For value, type pending. For expense type, enter the following. For type, select item. For value, select P3 expense type. Now you have defined the parameters. Click Save. You have created human task create process and configured the parameters. Understanding unified task list. The unified task list allows users to view, action, or edit task instances. When you configure the unified task list, you have different report contexts to choose from. My tasks are for users who are potential or actual owner of tasks. My task shows all tasks either assigned to the user or unassigned with the user as a potential owner. Tasks that are approved or rejected do not show in this list. My tasks sorts by descending creation date with newly created tasks at the top of the list. Admin tasks. For users who are business administrators of the tasks. Shows all the tasks that list under as a business administrator, including errored, completed, and cancelled tasks. Initiated by me. For users who have initiated tasks. Initiated by me shows all tasks that the user has initiated. The unified task list can be the same application as one of the task definitions or a completely separate application in the same workspace. If the unified task list is in a separate application, you must configure session sharing so users can still open the task details. Let us see a demo on creating unified task list. Creating unified task list. To create a unified task list, open the Create Page wizard. On the Workspace homepage, click App Builder. Select the application that needs a unified task list. On the application homepage, click Create Page. The Create Page wizard appears. Under Components, select Unified Task List. For page definition, set the following. Page number, an integer value that identifies a page within an application. Name, specify a text name for this page. The same text is also used for the page title. After page creation, the title can be modified using Page Designer. Report context. Select My tasks, admin tasks, or initiated by me. My task is for potential owner and actual task owners. Admin tasks is for the business administrators. Initiated by me is for the user who initiate tasks. In this example, let us select My tasks and set the page name as My approvals. For navigation, specify your navigation preferences and then click Create Page. Creating human task programmatically. The Apex_approval API package allows you to manage approvals and human tasks programmatically. The package includes functionality to create new tasks and handle lifecycle management for existing tasks. The package is a part of Oracle Apex workflow functionality. Runtime views for approvals. There are 5 public views available for the approvals component. Apex underscore tasks for the properties of each task instance. Apex underscore task underscore comments for all comments entered on each task instance. Apex underscore task underscore history for the chronological series of operations performed during the lifecycle of a task instance, including the user associated with the update and the date the operation was performed. Apex underscore task underscore parameters for the parameters defined for a task instance along with the computed runtime values in string format. Apex underscore task underscore participants for the list of participants on each task instance. Note that this list can differ from the list in the task definition due to the business administrators inviting new participants. In this lesson, you learned how to create human task page process and you understood unified task list. Then you learned how to create a unified task list page and understood how to create human task programmatically. I hope you learned something useful. Thank you for watching.
Welcome to this module on extending application capabilities. My name is Tawfiq. I'm Senior Product Manager for Oracle Apex. In this lesson about sending emails, you will learn how to send emails from Apex on OCI. You will also learn how to configure the email delivery service in OCI and configure the email settings in your development instance. Furthermore, you will also learn what is a mail queue and how you can monitor your mail queue as an instance administrator. Additionally, you will also learn about the Apex underscore mail PLSQL API using which you can send emails programmatically in Apex. Let's get started. Some of the points you need to know about sending emails from Apex on OCI are you can use the Apex underscore mail PLSQL API to send emails from Oracle Apex. So using this PLSQL API, you can send mails programmatically from PLSQL. But before you use Apex Mail or any other mailing features of Oracle Apex, you must configure an email provider in your Apex instance. Currently, the only supported email provider is the OCI email delivery service. To give you an overview of what are the steps involved in configuring emails in your Apex app are 1. First, you need to generate the SMTP credentials for the email delivery, which we do on the OCI console. And then we create an approved sender for email delivery. Once the email delivery service is configured on OCI, we then move on to the Apex instance and configure the SMTP parameters that are obtained after the first 2 steps. And then finally, we test whether the email configuration we have configured is working by sending a test mail using the SQL workshop in Oracle Apex. Let us have a quick demo of what we have learned so far. I'm on my Oracle Cloud console, the OCI console. The first step in sending emails from Oracle Apex is to create SMTP credentials. To do that, from the Oracle Cloud console, click on the hamburger menu and go to Identity and Security. Click on Users under Identity. Here you have to select the user you want to create SMTP credentials for. So I'm going to select the user here. And if I scroll down under resources, I find SMTP credentials. When I click on that, I get a button, generate SMTP credentials. So I'm going to generate SMTP credentials for this particular user. I can click on generate SMTP credentials and provide a description and click on generate SMTP credentials. Now I have generated the SMTP credentials. I need to copy the username and password. After copying the username and password, you can click on close. Now, once the SMTP credentials are generated, you can go to Developer Services from the hamburger menu and select Email Delivery under Application Integration. Under Email Delivery, you can click on Approved Senders. I can click on Create Approved Sender. Here you can define the email addresses that should be allowed to send mails. So whatever email addresses you provide as approved senders, only those email addresses can be passed as the from address for your emails. I'm going to create one sample email address and click on create approved sender. This email address is now approved to be used as the from header of your emails. Now once the approved sender is created, you can go to configuration. From here you can note down the public endpoint and the SMTP port. This information will then be configured in the Apex instance. After these endpoints are configured, let us go to the Apex instance. For that, I'm going to go to my Oracle database, autonomous database. Here, I already have an Apex instance provisioned. Go to the autonomous database and go to tools and click on open Apex. Now I'm going to log into the administration services. These are the credentials you would have provided while provisioning the autonomous database. Once I log in the administration services page, I'm going to click on manage instance and go to instance settings. Here I'm going to go to email tab and configure the email host address, which will be the public endpoint, and the username and password will be the credentials which I have copied when I generated the SMTP credentials. Configuring this, you can click on apply, and this completes the email settings configurations at the instance level. Now I can log out of this administration services and log into my workspace. Once inside the workspace, I can go to SQL commands and execute this piece of code, which is basically calling the apex mail.send with the email address. The from address should be the one which I have configured as an approved email sender, and the to address can be my address, and then this is the email subject and the body. Now if I click on run, the email is now submitted to the Apex engine, and because I'm using the push queue, the email will be delivered immediately. Now if I go back to my email, this is the email that I have received successfully. This is how you can configure and send emails from Apex on OCI. Let us understand what is a mail queue in Oracle Apex. When you submit a mail using the apex_mail PLSQL API or via any other mailing services available within Apex, the mails are not sent immediately. The mails are first added to a mail queue, which are then processed by a separate database job which runs every 5 minutes. As an instance administrator, you can manage emails sent from applications by monitoring email messages in the mail queue and mail log by logging into the Apex administration services. Using the mail queue, you can push, delete, or reset messages that are yet to be sent. To monitor the mail queue and take action on the mails in the mail queue, log in into the administration services. After logging into the administration services, click on Manage Instance. Under Manage Metadata, you will find Mail Queue. Click on that, and here all the mails that are waiting in the queue are listed, and you can also see the error field. Whichever mails are not sent because of the error are also listed here. You can select mails and click on delete to delete the mails from the queue, and you can also use force send all email to send all the emails by ignoring the calculated delay for the mails which encounter error, and you can use send all mail, using which you can send all mails by considering the calculated delay in messages which encountered error. So this is how you can manage the mail queue as an instance administrator. Let us understand a little bit more about the apex_mail package. Firstly, as I have explained earlier, you can use apex_mail PLSQL API to send emails from an Oracle Apex application programmatically. This package is a wrapper around the Oracle supplied util_smtp package. So apex_mail internally uses the util_smtp package that comes with the Oracle database. So you need to have the util_smtp package installed in your database to use apex_mail PLSQL API from Apex. Some of the main procedures and functions you would need in the apex underscore mail PLSQL package are apex underscore mail dot send. This is a function which returns an ID, and this submits the mail to the mailing queue. Apex underscore mail dot push queue. This is a procedure using which you can deliver the messages stored in the apex underscore mail underscore queue view manually. So instead of waiting for the database job to deliver these messages, you can use this push queue procedure to deliver all the messages waiting in the queue manually. And the last procedure is the apex underscore mail dot add function. Using this procedure, you can add attachments to your outbound emails. So this procedure takes in the ID that is returned by the apex underscore mail dot send function, and using that ID, you can attach files as attachment to emails. And the final point about the apex underscore mail is that Apex installs the database job, and the name of the job is Oracle Apex Mail Queue. This job periodically sends all the mails stored in the active mail queue. If you are hosting Apex instance on an on-prem database or on a non-autonomous database, you will have to enable network services to send outbound mails in Oracle Apex. By default, the network services are disabled, and you would have to enable these services manually. You can do that by using the DBMS Network ACL admin package to grant necessary connect privileges to any email host for the Apex database user. In the absence of these connect privileges, you will face issues while sending outbound emails in Oracle Apex. If your emails are not being sent, you may want to check the network services whether or not they are enabled and the necessary privileges are granted to the database user. In this lesson, you have learned how to send emails using Apex on OCI. You have also learned how to configure the email delivery service on OCI. Furthermore, you have also learned what is a mail queue and how you can monitor the Apex mail queue as an instance administrator. Additionally, you have also learned about the apex underscore mail PLSQL API using which you can send emails in Apex programmatically. Hope you have learned something new. Thank you for watching. Welcome to this module on extending application capabilities. In this lesson about sending emails, you will learn how to define an email template and how to send emails using the email process type available in Apex. Let's get started. To explain the concept of email templates and the send email process type available in Apex, I'm going to use this demo application. This is an event reminder notification application which has various fields. What I want is, after filling these fields, if I click on send email, I want the email to be sent to whichever email address is filled in the to field. To do that, I'm going to go to the app builder. Here in the app builder, click on shared components, and under shared components, under user interface, you will find email templates. When you click on that, you'll be navigated to the email template screen. From the email templates page, to create an email template, click on create email template. This will take you to the template details. Here you can fill in the template name, the static identifier, it will be filled automatically, and the email subject. Email templates also support template directives. Using template directives, you can make use of conditional rendering. For this demonstration, I'm going to use the sample template. The sample templates are available on the right hand side. As you can see, there are 3 sample templates made available for you. You can use sample templates to get started with your email templates. For example, I'm going to go with the event reminder. As soon as I click on the event reminder, as you can see, the email subject is filled, and event name, which is a substitution string, is also used here. So are the other attributes that are filled based on the sample template. You can always edit these attributes to match your email requirements. And if you scroll down, here you can see the plain text format. You can also use advanced HTML formatting if needed. under the advanced section, you can load the default HTML and use this to modify advanced attributes of your email HTML. And scrolling down here under sample API usage, you can find a sample PLSQL code snippet using apex_mail.send to send emails using this particular template. In this code snippet, you can see how you can pass the event name, invitee, and other substitution strings which you find in this template. For example, if I change the substitution string to something else, the API usage reflects that. This gives you an example of how you can pass values to these substitution strings or placeholders that you use in this email template. Let me revert this back. With this defined, I can give a name and the static identifier is filled by default. With this defined, I'm going to click on create email template, which then creates the email template. Now going back to the page, what I want now is when I click on this particular button, I want to send an email. For this, I'm going to use the send email process type in Apex, using which you can declaratively send emails from Apex. So quickly I'm going to quick edit on this button, and this button is actually submitting the page, which is fine. And I'm going to go to the processing tab. In the processing tab, I'm going to click on processing section and create process. On the right hand side in the property editor, I'm going to give it a name and I'm going to select the process send email. Here I can define the to address. The to address comes from the page item. So this is how I can reference that. And I can also fill in the CC and type. And under email template, I can choose the email template that I have created. And as you can see, it has identified that this email template has 12 placeholders. And I can go there and assign values to each of these placeholders that are available in this email template. I'm going to choose. So the values from these items can be passed on to these placeholders in the email template. With these values set, I can click on OK. And I can scroll down and I want this to be executed only when the button is pressed. So I'm going to select that under server-side condition. I can also define a success message and error message. A point to note here is that the from address needs to be defined as an approved sender on the OCI email configuration, which we have discussed in the previous lesson. Here you can either hardcode that value or get it from a page item within the page, or you can also define application email address in the application attributes. You can go to shared components, application definition, and under application definition, you can define the application email from address, and whatever value you enter here will be assigned to app_email substitution string and can be used in all your send email process type. And click on apply changes. With that said, I can go back to my page and fill in these details. With these values filled in, when I click on send email, now I get a success message that the email has been sent. And if I go and check my inbox, I can find this beautiful email and you can see the email template in play here. So this is how we can use email templates and the declarative process type send email, which is available in Apex, to send emails. To summarize, in this lesson, you have learned how to define email templates in Apex. You have also learned how to send emails using the email process type available in Oracle Apex. Hope you have learned something new. Thank you for watching.
Welcome to the Oracle Apex Developer Professional course. In this module on managing application data, I'll be talking about understanding data load definition. My name is Rupesh Tokala and I'm the product manager for Oracle Apex. Let's get started. In this lesson, you will learn about data load definitions. What is a data load definition? You can add the data loading capability to an application by creating a data load definition and then a data load page. A data load definition comprises a data load definition, data profile, and data profile columns. Data can be loaded either to an existing table in your schema or to a collection. For each data profile column, You can define SQL expression, SQL query, lookups, or transformation rules. These definitions are used in the native data loading page process type. When you create a data load definition, the wizard prompts you to add a data loading page to your application. However, if a data load definition exists, you can add a data loading page later by running the create page wizard. A data loading page consists of a single page with a native data loading page process, which enables users to upload data from a file or copy and paste, preview the data, and then upload the data. Note, a data load wizard is not designed or intended to load hundreds of thousands of rows of data. While it is possible to use a data load wizard to load this high volume of data, you may encounter performance issues with both transmitting and loading large data files. Tools like Oracle SQL Developer and Oracle SQL Loader are better suited for loading large volumes of data. Key features of data load definition. New application data loading now supports CSV, XLSX, XML, and JSON formats. Column mapping will occur at design time, removing the burden on end users. Flexible column mappings based on simple names or regular expressions. Data conversion with transformation rules or lookup queries. Easy workflow for end users. Just upload the file, verify the preview, and load the data. Configure data loading to append, merge, or replace data with or without error handling. Simple new process type for data loading. Customize data loading pages as you wish. The Apex data loading PLSQL API is now available for custom processing. The maximum number of columns to load is 300. Note that legacy data load supports up to 45 columns. What is data loading capability? You can add the data loading capability to an application by creating a data load definition and then a data load page. The Create Data Load Definition wizard supports uploading of the following sample file formats: CSV, XLSX, XML, or JSON. The uploaded file format is saved as data profile format. This format dictates the type of file end users can upload. For example, if you create a data load definition using a CSV sample file, only TXT or CSV file types can be uploaded from a page using the data load definition. Similarly, if you create a data load definition using an XLSX sample file, only XLSX file types can be uploaded from a page. The slide includes sample images in which the data load definition is created on the EMP table using the emp.csv file. In this lesson, you learned about data load definition and the data loading page. I hope you learned something useful. Thank you for watching. Welcome to this module on managing application data. In this lesson, you will understand how to create data load page, and then you will learn how to create DML error log table. Finally, you will customize data load definitions and define error handling. Let us see a demo on creating a data load definition. To create a data load definition, on the application homepage, click Shared Components. The Shared Components page appears. Navigate to Data Sources and click Data Load Definitions. Click Create. For method, this task assumes you select from scratch, then click Next. For target, set appropriate values for name, employees data, target type as table, target owner, and table name, in this example EMP table. Click Next. For sample data, set source type as upload a file, then drag and drop or click Choose File to navigate to the file. Supported formats include CSV, XLSX, TXT, XML, and JSON. Click Choose File and upload file from your local directory. Then click Next. For map columns, column mapping is done automatically by matching the sample data columns with the table columns. Accept the defaults and set EMP number as primary key. In this example, we need to create a data load definition and add a data load page to your application. For that, click Create and Add Page. For Create Data Loading Page, set appropriate values for name. In this example, leave the remaining options to default. For data load attributes, select the data load definition to use. In this example, employees data. For upload data from, select file. For navigation preferences, select how you want this page integrated into the navigation menu. Then click Create Page. Now let us understand how to create a data load page using the Create Page wizard. If a data load definition exists, run the Create Page wizard to add a data loading page. When you create a data load definition, the wizard prompts you to create data loading page. You can also create it later by running the Create Page wizard. To create a data loading page by running the Create Page wizard, perform the following steps. On the workspace homepage, click the App Builder icon, select the application, and then click Create Page. On Create a Page, select Data Loading and click Next. On the Create Data Loading page, set appropriate values for name and page mode. Then for data load attributes, select the data load definition, in this example employees data, and for upload data from, select file. Now select your navigation preferences, then click Create Page. In this lesson, you understood how to create a data load page, and then you learned how to create DML error log table. Finally, we customized data load definitions and defined error handling. I hope you learned something useful. Thank you for watching. Welcome to this module on managing application data. In this video, we will discuss about understanding collections. Let's get started. In this lesson, you will understand collections and then you will learn how to create collections. What is a collection in Oracle Apex? Use collections to temporarily capture one or more non-scalar values. Collections enable you to store rows and columns currently in the session state so that they can be accessed, manipulated, or processed during a user-specific session. Just think of collection as a bucket in which you temporarily store and name rows of information. Every collection contains a named list of data elements or members which can have up to 50 character attributes, 5 number attributes, 5 data attributes, 1 XML type attribute, 1 large binary attribute or blob, and 1 large character attribute or clob. You insert, update, and delete collection information using PLSQL API apex_collection. The following are the examples of when you might use collections. When you are creating a data entry wizard in which multiple rows of information first needs to be collected within a logical transaction. You can use collections to temporarily store the contents of the multiple rows of information before performing the final step in the wizard, when both the physical and logical transactions are completed. When you are creating a data entry wizard in which multiple rows of information first need to be collected within a logical transaction, you can use collections to temporarily store the contents of the multiple rows of information before performing the final step in the wizard, when both the physical and logical transactions are completed. When your application includes an update page on which a user updates multiple detailed rows on one page, the user can make many updates, apply these updates to a collection, and then call a final process to apply the changes to the database. Understanding collections. In this slide, you create a collection named sample_collection and then add and modify member attributes. Creating a report based on collection. In this slide, you create a report based on collection. You can write a query based on collections and make a report by using the source type as SQL query and include your SQL query based on collection. Creating a collection using page process. Every member contains a named list of data elements or members which can have up to 50 character attributes, 5 number attributes, 1 XML type attribute, 1 large binary attribute blob, and 1 large character attribute clob. There are many methods to create a collection. In the example in the slide, you use a basic create_collection method to write your anonymous block, and then you use a page process to run your collection or PLSQL block on a button click. The create underscore collection method creates an empty collection with the provided name. An exception is raised if the named collection exists. Adding members to a collection using page process. Use the add underscore member procedure to add a new member to an existing collection. An error is raised if the specified collection does not exist for the current user in the same session for the current application ID. Gaps are not used when adding a new member. So an existing collection with the members of sequence IDs 1, 2, 5 and 8 adds a new member with the sequence ID of 9. In the example in the slide, you use the add member method to write your anonymous PLSQL block, and then you use a page process to run your PLSQL block on a button click. In this lesson, you learned about collections and then you learned how to create them. I hope you learned something useful. Thank you for watching. Welcome to this module on managing application data. In this lesson, you will understand REST-enabled SQL references, and then you will learn to create and edit REST-enabled SQL references. Understanding REST-enabled SQL references. Create REST-enabled SQL service references to execute SQL or PLSQL defined on a remote Oracle database. Oracle Apex installations that meet the minimum Oracle REST data services or ORDS requirements can execute any SQL through a REST endpoint. Developers create REST-enabled SQL references by defining a name, the endpoint URL, and authentication information within shared components. Oracle Apex passes the SQL or PLSQL query to ORDS over REST, and a self-describing JSON response is returned. The JSON object contains the result set metadata, the result data, and pagination details. Because REST-enabled SQL services are stored at the workspace level within Apex components, they are available to all applications within a workspace. Developers can utilize REST-enabled SQL references for interactive reports, interactive grids, classic reports, forms, master detail forms, calendars, JIT charts, trees, and PLSQL processes. References can also be used with calendars, JIT charts, trees, and PLSQL processes. REST-enabled SQL service reference requirements. Requirements for using REST-enabled SQL service references include a remote database that includes Oracle REST data services or ORDS 19.x or later on the front end. An administrator must enable RESTful services either at workspace level or instance level as described in enabling RESTful services and defining a path prefix for a workspace, and enabling RESTful services for an instance in Oracle Apex Administration Guide. REST-enabled SQL references requirements. Complete the following requirements before creating a REST-enabled SQL reference. Set up a remote Oracle database. On the remote Oracle database, install Oracle REST data services or ORDS 19.x or later. Tip: this ORDS installation is completely independent of the Oracle REST data services used as the Apex web server. Configure and enable the REST-enabled SQL service feature. See Configuring REST-enabled SQL service settings in Oracle REST data services installation, configuration, and development guide. Activate REST-enabled SQL services for the target schema on the remote database to be accessed by running ords.enable_schema. The REST-enabled SQL service is then available with a URL in the following format: http://host:/port/ords/schema. Let us see a quick demo on creating a REST-enabled SQL service reference. Creating a REST-enabled SQL service reference. To create a REST-enabled SQL service reference, perform the following steps. On the workspace homepage, click App Builder. Select an existing application. On the application homepage, click Shared Components. Under Data Sources, select REST-enabled SQL. On the REST-enabled SQL page, click Create. Under General, specify name and endpoint URL. Then click Next. For authentication, specify the appropriate credentials. Credential name, username, password, and verify password. Then click Create. Oracle Apex tests the REST-enabled SQL service. If everything has been done correctly, that is, you have included the correct URL, schema name, and password, the test REST-enabled SQL service message appears as shown in the table. Click Close. Editing a REST-enabled SQL service reference. To edit a REST-enabled SQL service, on the workspace homepage, click Application Builder, select the appropriate application, and click Shared Components. Under Data Sources, select REST-enabled SQL, click the remote server name or REST-enabled SQL service reference name. The edit page appears. Now you can change the REST-enabled SQL reference attributes. REST-enabled SQL attributes. Name. Enter a descriptive name for this REST-enabled SQL service. Endpoint URL. Enter the base URL for this REST-enabled SQL service. Prompt on install. Choose whether prompts for this REST-enabled SQL service should display when the application is being imported on another Apex instance. Authentication required. Choose whether this REST-enabled SQL service reference requires an authentication. Credentials. Select the credential to authenticate against. Session attributes. Initialization code. Enter code to be executed immediately after connecting to the REST-enabled SQL service and before the component SQL is being executed. Cleanup code. Enter code to be executed immediately after the component SQL is being executed. In this lesson, you understood REST-enabled SQL references, and then you learned how to create and edit REST-enabled SQL references. I hope you learned something useful. Thank you for watching. Welcome to this module on managing application data. In this lesson, you will learn to create reports and charts based on REST-enabled SQL references, and then you will learn how to configure REST-enabled SQL references on an existing page. Creating a report using REST-enabled SQL reference. The slide shows an example of a report created on a remote database using a REST-enabled SQL reference. The procedures for creating other report types are similar. Now, let's see a quick demo on creating a report using REST-enabled SQL reference. Creating a page using REST-enabled SQL reference. To create an interactive report using a REST-enabled SQL reference, navigate to the workspace homepage, click the App Builder icon. Select an application. On the application homepage, click Create Page. The Create Page wizard appears. On Create a Page, select Interactive Report. Under Create Interactive Report Page Attributes, enter the following and click Create Page. For page definition, specify page number, page name, and page mode. For data source, select REST-enabled SQL service. For REST-enabled SQL service, select a previously defined reference. For source type, specify the source of the new page. Reports can be based on tables or SQL queries. Select either table or SQL query. In this example, let us select the source type as table. For table or view owner, select the owner of the table on which you are building a report. For table or view name, select the table on which you are building a report. In this example, let us select EMP. For navigation, specify your navigation preferences and then click Create Page. Your interactive report page is created based on REST-enabled SQL reference. Specifying a REST-enabled SQL reference on an existing page. In this slide, you configured the existing components to point to a remote database using a REST-enabled SQL service reference. You have created a chart using REST-enabled SQL reference. The procedures for creating other report types are similar. Let us see a demo on specifying a REST-enabled SQL reference on an existing page. To configure existing components to point to a remote database using a REST-enabled SQL reference, view the page containing the components to be reconfigured in the page designer. On the workspace homepage, click the App Builder icon. Select an application and then select a page. Page Designer appears. In the Page Designer, in the Rendering tab or left pane, right-click on Body and click Create Region. For the new region we created, specify a title and change the identification type to Chart. In the Page Designer, select the region containing the component if not already selected and edit the source attributes. To specify a remote database for the chart, on the Rendering tab or left pane, find and expand the region containing the chart. Expand Series and select the series that defines the chart. In the Property Editor, under Source, edit the following. Location, select REST-enabled SQL. Remote server, select the defined REST-enabled SQL service reference. For example, lowcode REST SQL _example. For type, select how the data is queried. Select table or view or SQL query. For table name, select EMP. Configure the remaining attributes as needed. Under column mapping, select label as ename, value as SAL or salary. In this example, series is selected and the source points to a remote server called lowcode REST SQL _example. In this lesson, you created reports and charts based on REST-enabled SQL references, and then you configured REST-enabled SQL references on an existing page. I hope you learned something useful. Thank you for watching. Welcome to this module on managing application data. In this video, we will learn how to create and manage REST data sources. Let's get started. In this lesson, you will understand REST data sources, and then you will learn how to create and edit REST data sources. Understanding REST data sources. REST data sources enables developers to access representational state transfer, REST services, or generic JSON data feeds in applications, and use the data in Apex components such as reports, interactive reports, and interactive grids. A REST data source can contain one or many operations which are the references to a concrete external web service. Configurations at the REST source level are shared across all contained operations. REST data sources contain multiple operators that differ depending on the web service target. For a REST service, an operation is a specific service handler such as get, put, post, or delete. Developers assign to an operation a database action such as fetch multiple rows, fetch single row, insert row, update row, and delete row. However, you can assign each database operation only once to a REST data source operation. Oracle Apex provides direct integration of REST data sources in classic reports, interactive reports, calendars, charts, etc. Oracle Apex splits the endpoint URL of a web service into two parts. The server-specific part is stored as a separate entity called the remote server. You can reuse a remote server with multiple REST data sources if it uses the same server, port, and URL path prefix or context root. If you change the attributes of a remote server, the change impacts all REST data sources using the remote server. If you change the attributes of a remote server, the change impacts all REST data sources using the remote server. Remote servers make it easy to move a collection of REST data sources. For example, you can move from the test system to a production system by changing the URL within the remote server object. Let us see a demo on creating a REST data source. Creating a REST data source from shared components. To create a REST data source, navigate to the REST data sources page. On the workspace homepage, click App Builder, select an application. On the application homepage, click Shared Components. Under Data Sources, select REST Data Sources. On the REST Data Sources page, click Create. Under Method, select From Scratch or leave it to Defaults and click Next. Under General, specify REST data source type, name and URL endpoint. For REST data source type, select Oracle REST Data Services. For name, specify employee data and specify your URL endpoint. Then click Next. Under Remote Server, select Remote Server if it already exists, base URL. This is the base URL of the chosen remote server object. The HTTP endpoint URL of this REST data source is made up of the base URL and the service URL path. Enter the service specific URL path for this REST data source. The HTTP endpoint URL is built by appending this base URL specified in the remote server object. Click Next. Under Authentication, for authentication required, choose whether the new REST data sources requires authentication. In this case, let us leave it to default. Then click Discover. Click Create REST data source. Editing or deleting a REST data source. To edit or delete a REST data source, navigate to the REST data sources page. On the workspace homepage, click App Builder. Select the application. On the application homepage, click Shared Components. Under Data Sources, select REST Data Source. On the REST Data Sources page, click the REST source name. The REST Data Source page appears. To delete the REST data source, click Delete. To edit the REST data source, select the REST data source and edit the attributes. Click Apply Changes. Under REST data source, you can modify name. Name defines a descriptive name for this REST data source. REST data source type determines a REST data source type, which is either a built-in type or a type defined by REST source plugin. The following built-in types are supported: Simple HTTP, Oracle REST Data Services, Oracle Cloud Infrastructure OCI, Oracle Cloud Applications REST Service or SaaS REST Service, REST-enabled SQL query. Remote Server. Choose a remote server object for this REST data source. Under Operations, Operations contains the actual information about the external web service handler. Operations can be mapped to database operations, which enables Apex components to pick up the correct operation. Click Add Operation to add a REST data source operation, or click the Edit icon to edit an existing operation. The REST source operation page appears. You can modify the following options on the REST source operations page. Under Operation, URL name. The URL pattern is the last part of the web service endpoint URL. HTTP method. It defines a HTTP operation or method. Get, post, put, delete, patch to be executed on the REST web service. Database operation. Assign a database operation to this HTTP operation. Under Caching, select how the Apex engine can cache REST data source responses on the server side. In this lesson, you understood REST data sources and learned how to create and edit REST data sources. I hope you learned something useful. Thank you for watching. Welcome to this module on managing application data. In this video, we will learn how to manage REST data sources. Let's get started. In this lesson, you learn to create and manage REST data synchronization, and then you will create a Faceted search based on REST data sources. Managing data synchronization. Data synchronization enables developers to automatically sync the contents of a local table with data from a REST service. You can trigger data synchronization manually or on a regular schedule by using a scheduler job. Note that the create job privilege must be granted to the application's parsing schema in order to execute REST source synchronizations on schedule. Apex can create the local table based on the visible columns in the REST data source data profile. Because the table is a visible object in the database schema, developers can add indexes, change physical properties, or even add more columns. If the table is not in sync with the data profile, data synchronization continues to work for columns present in both the table and the data profile. Other columns are ignored. However, Apex generates SQL DDL statements to sync table columns back to the data profile. These statements can be added to the application as supporting objects. Data synchronization use cases. Common use cases using REST data source data synchronization include provide efficient reporting on large datasets coming from a REST service. Some REST services can return large amounts of result data that includes pagination. If a reporting requirement needs larger datasets, this can result in multiple HTTP requests and poorer response times. Also, no indexes or other database features can be used to speed up reporting queries. In this case, Oracle recommends enabling data synchronization to sync the remote data to local tables and have any reports based on local tables. Let us see a demo on configuring REST data synchronization. Accessing the REST data synchronization page. Access the data synchronization page by selecting a REST data source and then selecting Manage Synchronization on the right side of the page. To access the data synchronization page, navigate to the REST data sources page. On the workspace homepage, click App Builder, select an application. On the application homepage, click Shared Components. Under Data Sources, select REST Data Sources. On the REST Data Sources page, click the REST source name. In this example, click Employee Data. Click Manage Synchronization on the right side of the REST data source page. The data synchronization page appears. Configuring the REST data synchronization page. Configure data synchronization to automatically sync a local table with data from a REST service. You can trigger synchronization manually or on a regular schedule using a scheduler job. To configure data synchronization, navigate to the data synchronization page. The data synchronization page appears. Under Details, specify Local Table Owner. Select the schema of the local table to synchronize data to. By default, the application parsing schema is used. Synchronize to. Select either New Table or Existing Table and click Save. If creating a new table, the error message appears. For table name, specify a table name and click Save. Now click Create Table. You can see a notification table created or changed. Under Details, for synchronization type, select a synchronization type. Append rows to the local table. This is typically used when no primary key has been defined in the data profile. Merge rows into the local table. To use this option, the data profile must have a primary key defined. If a row for the given primary key value exists, the row is updated. Otherwise, the row is created. Replace. Empty the local table before loading new data. For synchronization type, let us leave it to default append. Synchronization schedule. Use the database scheduler calendaring syntax to define repeating synchronization schedules, such as every Tuesday and Friday at 4 p.m. or the second Wednesday of every month. This calendaring syntax can be provided manually using simple expressions, which can be built using Interval Builder by clicking the hammer icon adjacent to the input field. Creating a Faceted search using REST data source. In this slide, you create a Faceted search page using a REST data source. The procedures for creating other report types are similar. Let us see a demo on creating a Faceted search using REST data source. Creating a Faceted search using REST data source. To create a Faceted search using REST data source, navigate to the workspace homepage. Click the App Builder icon. Select an application. On the application homepage, click Create Page. The Create Page wizard appears. On Create a Page, select Faceted Search. Under Create Faceted Search Page Attributes, enter the following and click Next. For page definition, specify page number and page name. For data source, specify the following attributes. Data source, select REST data source. For REST data source, select a previously defined reference. In our case, employee data. For navigation, specify your navigation preferences and click Next. Apex maintains a dictionary cache containing information about table columns, foreign keys, and actual data. Based on this cache, Apex can propose appropriate facets and create them automatically. Click Create Page. In this lesson, you learned how to create and manage REST data synchronization, and you also learned how to create a Faceted search based on REST data source. I hope you learned something useful. Thank you for watching.
Welcome to Oracle Apex Developer Professional Course. My name is Taufeeq. I'm Senior Product Manager for Oracle Apex. Security. Authentication and authorization are two building blocks to build secure web applications. In this module about implementing security, you will learn how to implement authentication in your applications using pre-built authentication schemes available in Apex. You will also learn how to implement role-based access control using authorization schemes available in Oracle Apex. In this lesson, you will start with understanding how to build secure applications. Additionally, you will learn what is authentication and how to create authentication schemes in Oracle Apex. Let's get started. After you create an application, you generally need to ensure that only authorized users can access the application and the unauthorized users are restricted. The primary thing in building a secure web application is to understand who the accessing user is. You use a login page with username and password as an access entry to an application. Only if the login succeeds, the user is allowed access to the application. Confirming a user's identity before allowing access to the application is known as authentication. After successfully logging into the application, the next question is, what is the logged in user allowed to do? Can the user get access to a page or a page component? Authorization covers this aspect of implementing security in an application. Authorization refers to restricting access to specific pages and components based on user privileges. Let us start with understanding what is authentication. Authentication is the process of establishing each user's identity before they can access your application. It may require a user to enter a username and password, or could involve the use of digital certificates or a secure key. If all the users have the same rights and privileges, they are referred to as public users. However, if your application must track each user individually, you must specify an authentication method. In Apex, the Apex engine uses app user to track each user's login in session state. Many authentication processes require that a user provides some type of credentials, such as username and password. These credentials are then evaluated and they either pass, which then allows access to the application, or they fail, denying access to the application. Once the user has been identified, the Apex engine keeps track of each user by setting the value of the built-in substitution string app user. Coming to different ways you can choose an authentication method in Apex. There are three ways broadly. One is you can select a built-in authentication scheme. In Apex, you have pre-configured authentication schemes. You can select one of these built-in pre-configured authentication schemes and design your authentication method around these built-in schemes. Another option is you can create a custom authentication scheme, which gives you complete control over the authentication interface. In this approach, you must implement a PLSQL function that the Apex engine can use to authenticate your users. And the third option is that you can choose to not have any authentication. If you choose this authentication approach, Oracle Apex does not check any user credentials, and all the pages of your application are accessible to all the users publicly. The following are the pre-configured authentication schemes that are shipped with Oracle Apex. The first one is Oracle Apex accounts. Oracle Apex accounts are user accounts that are created and managed in the Apex user repository. In this authentication scheme, your application is authenticated against these Oracle Apex accounts. The next one is custom authentication. As I have mentioned earlier, you can also create a custom authentication scheme from scratch to have complete control over your authentication interface. You can also authenticate using the database schema accounts. In the HTTP header variable authentication scheme, the authentication is done externally and the username is stored in the HTTP header variable by the web server, which is then used to authenticate the user. You can also use open door credentials as an authentication scheme, wherein it enables anyone to access your application using a built-in login page that captures the username. You can have no authentication as one of the authentication schemes. This adopts the current database user. This approach can be used in combination with a mod PLSQL DAD configuration, database access descriptor configuration, that uses basic authentication to set the database session user. You can also authenticate against an LDAP directory, wherein the entered username and password is authenticated with an authentication request sent to the LDAP server. You can also delegate the authentication to the Oracle application server single sign-on infrastructure. To use this authentication scheme, your site must have been registered as a partner application with the SSO server. You can also use SAML sign-in using third-party identity providers which support SAML. You can also authenticate using social sign-in. Apex supports authentication with Google, Facebook, and other social network that supports OpenID Connect or OAuth 2 standards. Enough of theory, let's click some buttons. Let us see where you can find authentication schemes in Oracle Apex and how to create authentication schemes. For that, I will be creating an application from scratch. Once the application is created, you can see it has three pages: global page, home page, and the login page. This is where the authentication is performed. So when you run this application, you will be presented with a login form with username and password fields. So what username and password should I use here? When you create an application in Apex, that application by default uses Oracle Apex accounts based authentication scheme. You can see that from shared components. Under security, click on authentication schemes. This is where all the authentication schemes that are defined in this application are listed. As you can see, there is one authentication scheme called Oracle Apex accounts, and the suffix -current indicates that this is the current authentication scheme that is being used for this application. This scheme is of type Oracle Apex accounts. That means it uses the users that are defined in the Oracle Apex user repository. If you are a workspace administrator, you can go to manage users and groups, and this is where you can create users in the Oracle Apex user repository, which can then be used to log in into this application. Let's go back to the authentication schemes page. To create a new authentication scheme, you can click on create button. You can create a new authentication scheme based on pre-configured schemes from the gallery, wherein you will be presented with built-in scheme types, or you can create a new authentication scheme as a copy of an existing authentication scheme. For now, I'll be going with the pre-configured scheme from the gallery option. Here on the create or edit authentication schemes page, you can enter a name for your authentication scheme, and I'm going to call it my auth scheme. Under scheme type, you will find different scheme types that are pre-configured and comes out of the box from Apex. Various scheme types include the custom authentication scheme. As I have explained earlier, using custom authentication scheme, you can build your authentication scheme from scratch, which gives you full control over your authentication interface. You can also use database credentials to log in using the database accounts scheme type. And you have other scheme types like HTTP header variable, LDAP directory, open door credentials, social sign-in, so on and so forth. If you select custom authentication scheme type, you get other options like sentry function. So here you need to mention the name of a sentry function, which will be called to establish whether or not the session is valid. So every time a page is rendered or a page is submitted or an AJAX request is made to the database server, the sentry function is called to establish whether or not the session is valid for every such request. If the sentry function returns false, the session is marked as invalid, and then the invalid session procedure is called. The sentry function can be defined here under source PLSQL code or in the package, and its name can be configured in the attribute here. Same is also the case with the other function name and procedure name attributes which you see here. Coming to authentication function name, this is where you define the authentication function which will be used to validate the user credentials. For example, I have a function like this called my authentication. It takes two parameters, username and password. The signature of this function cannot be changed, it's fixed, and it returns boolean. If you look at what I'm doing in this function is I'm querying the users table, getting the password, the hashed password into a hash variable, and here I'm checking whether the entered password after hashing is same as the hashed password that is stored in the database. If this matches, the user is authenticated successfully and it returns true, otherwise this returns false. So once this function logic is defined, you can just mention the function name in the authentication function name like this. Under post logout procedure name, you can define the procedure which will be called after the logout is performed. This is how we can use various functions and procedures to perform authentication. For this demo, I'll be going with a simple scheme type like open door credentials, wherein every user will be able to access your application and a built-in login page will be used to capture the username. So with this scheme selected, I can click on create authentication scheme. Now you can see the newly created authentication scheme is set as the current authentication scheme. With this set, when I run this application, I will be presented with a built-in login page which asks for a username. When I enter the username, click on login, I will be navigated to the home page indicating a successful login. So this is how you can create an authentication scheme based on built-in schemes in the gallery. Let us see how to create an authentication scheme as a copy of an existing authentication scheme. For that, I click on create button, and this time instead of using the based on a pre-configured scheme option, I'll be going with the second option, which is as a copy of an existing authentication scheme. And I click on next. On this page, I can select from which application I want to copy the authentication scheme. You can either select the current application or any other applications that are available in this workspace. And click on next. Here, all the authentication schemes that are available in the selected application are listed, and you can toggle the copy select list to yes to copy this particular authentication scheme and give it a meaningful name. Now when I click on copy scheme, the corresponding scheme is copied. You can also use subscription model to manage your authentication schemes. In the subscription, you can select a master authentication scheme and apply changes. Now this new theme is subscribed to the master authentication scheme. This is particularly useful if you have multiple applications using the same authentication. What you can do, you can have all the authentication schemes in one application, and the authentication schemes in all the other applications can subscribe to this master application. And whenever you make changes to the authentication schemes in the master application, you can simply publish these changes to all the subscribed schemes using the publish scheme button. So using the subscription model, you can easily manage your authentication schemes without having to do individual changes. In this lesson, you have learned how to build secure applications. You have also learned what is authentication and how to create authentication schemes in Apex. Hope you have learned something new. Thank you for watching. Welcome to this module on implementing security in your applications. In this lesson about understanding Understanding and using authorization schemes, you will learn what is an authorization scheme and how to create and configure authorization schemes in Oracle Apex. Let's get started. After successfully logging into the application, the next question is, what is the logged in user allowed to do? Can the user access every page or page components? Authorization covers this very aspect of implementing security in your applications. So what is authorization? Authorization refers to restricting access to specific pages and components based on user privileges. In Apex, you can use authorization schemes to implement authorization in an application. We can apply an authorization scheme for an entire application, for a page, for specific components such as regions, items, or buttons. How to implement authorization scheme in Apex? Apex allows you to implement authorization schemes in two different ways. The first one is by navigating to shared components, and there you can either create an authorization scheme from scratch or can create an authorization scheme as a copy of an existing authorization scheme. The second option is by using the access control page. You can create an access control page and then configure the access control page by setting the application mode and then adding users to the access control list. After that, we can apply the authorization scheme to application components. Let us see how to create an authorization scheme. For that, go to Shared Components, and under Security, right under Authentication Schemes, you will find Authorization Schemes. When you click on that, you will be navigated to the Authorization Schemes landing page where all the authorization schemes that are created in this application are listed. There is one authorization scheme that is created by default with all new applications called Administration Rights. You can click on that and see what this authorization scheme is all about. Currently, this authorization scheme does nothing. It just returns true always. If you look at the scheme type, here you get various options on how to evaluate your authorization scheme. For example, you can write a PLSQL function which returns true or false. Here you can specify the error message which would be displayed if this authorization scheme returns false. You can also specify the evaluation point. Here you can specify how often do you want to execute this authorization scheme. For example, if you choose once per session, this authorization scheme will only be executed once at the starting of the session and the results are cached. This can be used when the result of this authorization scheme is not going to change after the session has been established. You can also define to execute this authorization scheme once per page view, once per component, and always. So when you specify always, that means every time the component is rendered, this authorization scheme is executed and its result is evaluated. These are the different settings you get under authorization scheme. Let's create an authorization scheme. As I have mentioned earlier, you can create an authorization scheme from scratch or you can copy an existing authorization scheme. So I'm going with the first option. I'm going to create an authorization scheme from scratch. Now I can give a name. You can give any meaningful name. The scheme type, I will be selecting value of item in expression 1 equals expression 2 as a scheme type. And under item, I'm going to use app user, which has the value of logged in username. Under value, I'm going to provide manager. What this means is whichever component has this authorization scheme, that component will only be accessible to the user with username manager. If any other user tries to access that component, it will not be accessible. And I can define an error message and I can leave the evaluation point to be once per session because the app user is set at the session level and it won't change once the session is established. So once per session is fine in this particular case. With that defined, I can click on create authorization scheme to create this new manager only access authorization scheme. Now this authorization scheme is created. Now let us put this authorization scheme to use. For this demo, let us apply this authorization scheme to the entire application. For that, let me go to Application, Shared Components. Under Shared Components, I can click on Security Attributes And on the security page, you see a section called authorization. Here you have an attribute called authorization scheme. You can select the newly created authorization scheme. This authorization scheme is applied to the entire application. You can click on apply changes. Now if I go back to the login screen and log in with a random user who is not a manager, I get the error message which I have defined, only accessible to managers. Now if I go back and log in as manager, I have complete access to the application now. So this is how you can use authorization scheme to restrict access to specific components like the entire application or a page or a region. Now let us see how to apply this authorization scheme to a specific page and various components in the page. For that, let me first remove this authorization scheme at the application level. Once that is done, now what I'm going to do is I'm going to apply this authorization scheme to this create form, which is page 3. I can go to page 3. On page 3, I can scroll down to security. That is where I get an option to select an authorization scheme. I can select the newly created authorization scheme, manager only access, and save. Now let me log out and log in again. Now when I log in with a random user, this application is accessible because this application does not have the authorization scheme now. But when I click on create, because this page has the authorization scheme specified, which provides access only to managers, this page is restricted to be accessed. I can make it more granular. So going back to the page, I can remove this authorization scheme from the page level. Instead, I'm going to apply this authorization scheme in the employees grid. So we have this create button, right? I'm going to apply the authorization scheme on this create button and click on save. Now when I log out of this application and log in as a random user, now you can see the application is accessible, the page, which is the employees page, is accessible, but the create button is not accessible because of the authorization scheme applied at the button level. Now if I log out and log in as manager, now you can see the button is back because manager has access to this button. This is how you can use authorization scheme to control access to specific components on your page based on user privileges. Moving on, you can also create an authorization scheme as a copy of an existing scheme. Let us also see that. For that, click on create. This time I'm going to go with as a copy of an existing authorization scheme. Click next. Just like in the case of authentication scheme, here also I'm provided with an option to select an application from which I want to copy this authorization scheme. And here all the authorization schemes from the selected application are listed. I want to copy this one, give it a meaningful name, and toggle the copy select list to yes. And this will create a new authorization scheme as a copy of an existing authorization scheme. Just like authentication schemes, authorization schemes can also be subscribed to a master theme. This is how you can create and manage authorization schemes in your applications. Additionally, you can also view authorization reports. For example, if you go to subscriptions tab, here you get the details about the subscribed authorization schemes. If you go to by component, here you can see which component is using which authorization scheme. You can also see the utilization of various authorization schemes here under the utilization tab, and under history All the change history of various authorization schemes is listed here. To summarize, in this lesson, you have learned what is an authorization scheme and how to create and configure authorization schemes to restrict access to an application, page, or page specific components in Oracle Apex. Hope you have learned something new. Thank you for watching. Welcome to this module on implementing security in your applications. In this lesson, you will learn how to create and use access control administration page and assign roles to users in your application. Let's get started. In the access control list, you can control access to an application, individual page, or page components. When you run the access control wizard, it creates multiple administration pages and the following components. It adds an access control region to the administration page. You can either specify an existing page as the administration page or a new page can be created. It also creates various roles like administrator, which correlates with the administration privilege, contributor role, which correlates with the edit privilege, and the reader role, which correlates with the view privilege. It also creates various authorization schemes such as administration rights, contribution rights, and reader rights. It also creates a build option, feature access control, and it creates an application setting, access control scope. We can use the access control list to associate the access roles with application users. Let us see how to create and use access control administration page. For that, I'll start with creating a new application. In application creation wizard, under features, you can find access control as one of the features. I'm going to check that and create application. In the new application that is created, alongside the global page, home page, and the login page, you also find additional pages created because we checked the access control feature while creating the application. And if we go to the shared components and click on application access control, we'll also find three different roles that are created as we have discussed earlier. One is administrator, contributor, and reader. And if we go to the authorization schemes, three different authorization schemes are created. One is administration rights. This authorization scheme checks whether the authenticated user has the administrator role. The contribution rights authorization scheme checks whether the authenticated user has administrator or contributor role. And if you look into the reader rights authorization scheme, it first checks whether every authenticated user should be allowed to access the application. If that setting is configured, then it will return true, meaning every authenticated user will be allowed to access. And if that setting is not enabled, then it checks whether or not the authenticated user has at least one role. Only then this authorization scheme evaluates to true, thereby allowing access. So with that setup, let us go and create a page. I'm going to be creating an interactive report on EMP table. Once this page is created, if I run this application, I will be presented with a login screen. And in this application, I have created two users. One is Pat, the other is Steve. What I want now is to add Pat and Steve as users to the access control list and associate roles to them. For that, I'm going to log in as administrator. Once I log in as administrator, I have access to the access control administration page. Here I can add user by clicking on the add user button, and I'm going to add Steve and assign contributor role to Steve. I'm also going to add one more user, Pat, and I'm going to assign reader role. That means Pat can only view data but cannot create data. That's the role I'm going to assign to Pat, and click on add user. Now two users are added. You can see all the users by clicking on users. So here are the users. Pat as reader, Steve as contributor. And you can also define access control. Here, if you want to allow every authenticated user to be able to access the application, you can enable this. That is what we saw in the readers write authorization scheme. So we'll keep this disabled for now. With the roles assigned to users, if I log out and log in as Steve, Steve will have access to the application. And now if I log in as Pat, Pat will also have access to the application. But since Pat is a user who has only view privileges, when Pat logs in, he should not be seeing the create button. For that, I can go to the button and assign the contribution rights authorization scheme for this button. With that said, if I go back to the application and refresh the page, now you can see the create button is not available for Pat. Whereas if I log in as Steve, who is a contributor, the create button is available for Steve. This is how you can use access control administration page to assign roles to application users and control access to specific components. Additionally, you can also assign roles to users from shared components. Go to application access control, and here you can add user role assignments from this page. For example, I want to make Taufik as administrator, create assignments, and if I go back to the application and log in as Taufik, since Taufik is now added as administrator, I have access to the administration access control page. To summarize, in this lesson, you have learned how to create and use access control administration page. You have also learned how to use authorization schemes, which comes pre-built when you create access control administration page. Hope you have learned something new. Thank you for watching. Welcome to Oracle Apex Developer Professional course. My name is Taufik. I'm Senior Product Manager for Oracle Apex. In this module on adding new pages to your application, you will learn how to add chart pages in Apex. You will learn how to create and use various chart types like area chart, bar chart, line chart, pie chart, and range chart. You will also learn how to customize these charts using chart attributes available in Oracle Apex. In this first lesson, you will learn about area chart and how to create and customize area charts in Oracle Apex. Let's get started. Oracle Apex supports charts based on Oracle JavaScript Extension Toolkit, also known as Oracle Jet, data visualizations. Oracle Jet empowers developers by providing a modular open source toolkit based on modern JavaScript, CSS3, and HTML5 design and development principles. This lesson covers a few examples of native charts that are available in Oracle Apex. You can add a chart to your application by running a built-in wizard or by creating it manually in Page Designer. The chart you see on the screen is an area chart built using Apex. The SQL query beneath it is the one that is used to generate the chart series. Once you build a native chart in Apex, you can then use the chart attributes to format and customize the style of your chart. Let us see how to create an area chart and how to customize the chart styling using various chart attributes. To create a page with an area chart, click on Create Page. Under Create Page, click on Chart. Here you are presented with all the chart types that are available. Click on Area. Give a name to this page which contains the area chart. And instead of using a table, I'm going to go with a query. Once this query is pasted, click on Next. And here you can define what orientation you want for the chart, whether you want the chart to be displayed in a vertical orientation or in a horizontal orientation. I'm going to go with vertical. You can also select what will be the label column, which will be shown on the x-axis, and the value column, which will be shown on the y-axis. You can also define the maximum number of rows you want to use while displaying the chart. Then click on Create Page, which will create the page. In this page, you can see a region of type chart is created, and if you go to attributes, type of this chart is area, and this chart has one series where the query which we pasted is being used. Let us run this page to see how the area chart looks like. Based on the SQL query, you can see the chart being displayed here. This displays an area chart with the products and the quantity of the products ordered by this particular customer. Now, I also want to display the same area chart for other customers. And I can do that by adding more series in this chart. First of all, I'm going to name this daily because this series is related to the customer daily. And I'm going to duplicate this series. I'm going to use a different customer here, store A, and the same should also reflect in the query. Now I have created two series in this area chart. The first series is named daily, which shows the information about the customer daily, and the second one shows the information about store A. Now if I save and run my page, as you can see, both the charts are displayed. When I hover on that particular chart, it is highlighted and the other chart is dimmed a bit for you to easily visualize. I can also stack the charts one on top of other. To do that, I'm going to go to the chart region and go to attributes. Under appearance, you can find stack as one of the attributes. It is currently disabled. Now if I enable this, save and run the page, now the charts are stacked one on top of other. I can also show a legend. Let me go back to the page. Under attributes, here you have a property group legend where you have an attribute called show. Toggle the show attribute and I click on save. Now if I go and refresh the page, here you can see a legend is added. I can just click on the particular series in the legend and that series will be hidden. This behavior is driven by the hide and show behavior you can find in the property legend. So if you want to disable that behavior, you can just select none. The other options include rescale. Using this option, the chart axis will rescale based on the minimum and maximum values of the visible data. And if you just want to have hide and show behavior and no rescaling of the chart axis, you can just select no rescaling. You can also customize the line types a series can have. For example, if I go to Delhi and scroll down on the right side to line, it shows automatic. I can choose to have a curved line for the area chart. Do the same for store A. Now, when I go and refresh the page, you can see the line is now curved instead of being a straight line. I can also choose to have markers, and I can give a shape, for example, circle, and refresh the page. Now you can see each data point is highlighted with a marker. And now if you choose to change the orientation, you can do that from attributes and make it horizontal. And when you refresh the page, now the chart is horizontally displayed with the labels on the y-axis and the quantity on the x-axis. This is how you can use chart attributes to customize the look and feel of your charts. To summarize, in this lesson, you have learned how to create an area chart in Apex. You have also learned how to declaratively customize the styling of an area chart using various chart attributes available in Oracle Apex. Hope you have learned something new. Thank you for watching. Welcome to this module on adding additional pages to your applications. In the previous lesson, you have learned about area chart. In this lesson, you will learn about bar chart and line chart. You will also learn how to customize these charts using chart attributes available in Oracle Apex Page Designer. Let's get started. This is how a typical bar chart looks like in Apex. The bar chart on the screen shows projects and their over budget and under budget information displayed as a stacked bar chart. To create a bar chart, click on Create Page, select Chart. From the available chart types, click on Bar. Enter a name for the new page which contains the bar chart. And for source type, I'm going to go with SQL query and paste the query. What this query does is it calculates the sum of budget for all the tasks where the task budget is greater than task cost and labels that as under budget, and it also calculates the sum of budget for all the tasks where the budget is less than the task cost and labels it as over budget. It also gives green color for under budget and red color for over budget. With this query defined, click on Next. For the label column, select Label, and for the value column, select Value. Then click on Create Page. This creates a page with a chart region of type bar and a series, which is using the query which we have pasted. Since this query also has series name dynamically generated, we can mention the same in the column mapping, a series name. Once that is done, we can see the bar chart generated. Just like in area chart, you can also make this bar chart stacked. To do that, you can go to the chart region, under attributes, toggle the stack, go and run the page. And now you can see the series is stacked one on top of other. You can also mention whether or not the stack label should be shown, and this displays the total values of the stacked data. Additionally, you can also utilize the color that is coming from the SQL query to fill the bar in the bar chart by using the ampersand substitution string. With that defined, we run the page. Now you can see the bar chart being displayed in the color that is coming from the SQL query which we pasted. You can also use stack category to stack specific series. To do that, I'm going to use a different query here, and I'm going to name this that name value quantity. I'm going to create similar series. and one more. Now, with this bar chart, I only want to stack store A and Acme store together and not stack Delhi, for example. So what I'm going to do is I'm going to go to store A and scroll down to appearance. Here, for stack category, I'm going to mention stack 1 as the category name, and I'm going to use the same category for Acme store series as well, and mention a different category for Delhi. For example, stack 2. With the stack category defined for all the series, now if I run the page, you can see that the series store A and the series Acme store are stacked and the series Delhi is not stacked. Now if I go and change the stack category of Delhi to stack 1 and refresh the page, now all the three series are stacked because of the same stack category. Additionally, you can also change the format of y-axis to display in percentage instead of absolute values. To do that, go to Page Designer, go to y-axis. Under Value Property Group, you have an attribute called Format. Change that to %. Now, if you run the page, we can see the y-axis showing percentages and the chart displaying the percentage instead of absolute value. Let me change it back to decimal. You can also have a dual y-axis. For example, I want to display the Acme store in a separate y-axis. So to do that, I can go to the Acme store series, scroll down to appearance. Here, there is an attribute called assign to y2 axis. Toggle that. Now you can see an additional y-axis is added. Go there, give a title, and you can scroll down, and on the dual y-axis you can toggle yes, and for splitter position provide a number. This determines the fraction of the space that is given to the y-axis. With that set, you can go back and refresh the page, and now you can see that the Acme store series is now displayed in a separate y-axis. This is how you can create a bar chart and customize the chart attributes for a bar chart in Apex. The next chart we're going to learn about is the line chart. On the screen, you see how a typical native line chart looks like in Oracle Apex. To create a line chart, click on Create Page, select Chart, select Line Chart, give a name to this new page which contains the line chart, and for source type, I'm going to use the same SQL query which we have been using in the previous demos, and click on Next. For label column, select product name and the value will be quantity. Click on Create Page. This creates a region of type chart, and if you go to attributes, the type is line, and the series will be using the same SQL query which we have pasted earlier. With that, if we run the page, we can see the line chart displayed based on the SQL query. You can customize the line styles and type from the series level attributes. You scroll down, here you find under line property group the style, whether you want a solid line, dotted line or dashed line. You can also define the type, for example curved. And this is how you can control the line type and line style. You can also add markers by going to marker, property group and selecting S. The shape can be diamond, for example. And you can also specify the label position by going to the label position, and for example, if you make it above marker, you can see the quantity values are being shown above the marker. You can also choose a different position, for example, below marker, and now you can see the label positions changed to be displayed below the marker. You can also change the orientation by going to the attributes and make it horizontal, and orientation can be controlled like this. To summarize, in this lesson, we have learned how to create a bar chart and a line chart in Oracle Apex. You have also learned how to customize the styling of these charts using various chart attributes available in Oracle Apex Page Designer. Hope you have learned something new. Thank you for watching. Welcome to this module on adding additional pages to your application. So far in this module, we have covered area chart, bar chart, and line chart. In this lesson, you will learn how to create a pie chart and a range chart in Oracle Apex. You will also learn how to declaratively customize the styling of these charts using various chart attributes available in Oracle Apex Page Designer. Let's get started. On the right hand side, you see how a native pie chart looks like in Apex. And on the left side, you see a SQL query used to create this pie chart. To create a pie chart, click on Create Page and then click on Chart. From the available chart types, select Pie Chart. On this page, enter a name for the newly created pages which will contain the pie chart. And for source type, I'm going to use a SQL query based on the projects and corresponding tasks data. With the SQL query defined, click on Next. Provide a label column which will be the project and the value column which will be the sum of cost, and click on Create Page. This creates a region of type chart, and under attributes you can see the chart type is a pie chart, and for the series it uses the SQL query which we pasted. With this created, when I run the page, you can see the pie chart here. Now, when I select a segment in the pie chart, you can see it is being highlighted. I want to have a different pie selection effect. For that, I can go to the chart, go to attributes. If I scroll down, under settings, there is an attribute called pie selection effect. Because it is set as highlight, that is why when you select a segment in the pie chart, it is just highlighting with a black border. Instead, if I want to use highlight and explode, for example, and if I refresh the page, now when I select a segment, it explodes out of the pie chart and it gets highlighted with the black border. Additionally, I can also choose to only have explode, wherein the segment only explodes out of the pie chart and you will not see the highlight border. That is how you can define a pie selection effect. Additionally, I can also define automatic refresh interval. Let's say if I define it 10 seconds. With this setting set, what happens is the chart refreshes itself every 10 seconds, thereby fetching the fresh data from the database. This is particularly useful when this pie chart is part of a dashboard and you need to refresh the pie chart automatically at a specific intervals. Now, what I want to do is I have an interactive grid which displays all the project and task details. We run this page and show it to you. This has an interactive grid with project, task name, and other details. Now what I want to do is when I click on a segment which corresponds to a project in this pie chart, I want the chart to navigate to the interactive grid and filter the records based on the selected project. To do that, I'm going to go to this particular pie chart and I'm going to go at the series level. If I scroll down, I have a property group called link. Here, I'm going to select redirect to a page in this application. And in the target, I'm going to select the corresponding page number. I'm going to use IG underscore syntax to set the value of a column filter, and the value would be the ID column. Make sure the action is clear regions so that the previously applied filter is cleared out every time the page is requested. With that set, refresh the page. When I click on a particular segment, it navigates to this interactive grid and it applies a filter based on the selected project. If I go back and select a different project, let's say bug tracker, it filters all the bug tracker related tasks in this interactive grid. So this is how you can link a different page from the pie chart and navigate to that page. The next chart you're going to learn in this lesson is the range chart. On the screen, you see how a native range chart looks like in Oracle Apex. Range charts support two types of series, bar range or area range. For range charts, each data point may have up to two labels, one for the low value and one for the high value. To create a range chart, click on Create Page and select Chart. From the available chart types, select Range. Enter a name for the page that will be created that holds the range chart. For the source type, I'm going to use SQL query. This SQL query fetches the product name, minimum quantity of orders for a given product, and the maximum quantity of orders for a given product. These values will be displayed in a range chart. After filling the select statement, click on Next. Here, select the label column, which will be product name, the low value column, which will be minimum value, and the high value column, which will be maximum value. After configuring these columns, click on Create Page. Once the page is created, you can see this page has a chart region of type range, and it also has a series of type bar range chart, which is the default type of range chart that will be created, and it uses the SQL query which we provided. Now if I run this page, you can see the range chart that is created based on the SQL query, which has a minimum value and a maximum value for each product. Now this is range chart of type bar. Range chart can also be of type area. To change the type, you can simply go to the series and select area range and click on save. Now if I go back and refresh the page, you will see the range chart being displayed as an area range chart. Now you can also customize the line type for this chart by going to the series, and here on the right hand side you see a property group called line. For type, you can select none, and once you save and refresh the page, you will find that the lines connecting the maximum and minimum values are not shown anymore, and you see a straight line connecting the maximum and minimum value. This is how you can create and customize a range chart in Oracle Apex. I would also like to mention about the sample charts application, which you can download from the gallery. Under sample apps, you can find the sample charts application, which you can install, and this sample application has examples of all the chart types that are available in Apex. This will be a good reference point for you if you're working with charts. You can also access this application by simply going to apex.oracle.com/go/sample_charts. To summarize, in this lesson, you have learned how to create a pie chart and range chart in Oracle Apex. You have also learned how to declaratively customize the styling of these charts using various chart attributes available in Oracle Apex Page Designer. I have also mentioned about the sample charts application where you can find examples of all the chart types available in Oracle Apex. Hope you have learned something new. Thank you for watching. Welcome to this module on adding additional pages to your application. In this lesson about creating, customizing, and using calendars, you will learn how to display event-related data in your Apex application using calendar region. Oracle Apex has a built-in calendar region type using which you can display calendar events in your Apex applications. App Builder includes a built-in wizard for generating a calendar with monthly, weekly, daily, and list views. Calendars in Apex can be based on a table or a SQL query you provide. During the creation process, you are prompted to select a date column and a display column. On the screen in the calendar region, you can see on the top left corner a few buttons. These are previous and next buttons, using which you can navigate to the previous month and the next month. On the right hand side, you can see month, week, daily, and list buttons, using which you can change the view in the calendar. For example, when you click on month, it displays all the orders that are placed in a given month. Using the list view, we can see the list of all events in the underlying source query. The calendar region in Apex also supports moving or changing calendar events with drag and drop. So let's say you want to change the event review beta feed from Jan 4th to Jan 6th. You can simply drag and drop that event in the calendar using the drag and drop functionality available in Apex. To enable drag and drop, you just need to toggle the drag and drop attribute available in Page Designer for the calendar region. You can also specify a PLSQL code that should execute when the drag and drop event occurs. In the previous example, when you drag an event from Jan 4th to Jan 6th, you would want to update the start date and end date of this task in the underlying table as well. You can do that by specifying the update statement in the drag and drop PLSQL code. So when the user drags and drops the task from Jan 4th to Jan 6th, this PLSQL code executes and the start date and end date of this particular task are also updated in the database. Let us see how to create a calendar page in your Apex application. So I am in this application called Calendar Demo. Here I'm going to click on Create Page. In the Create Page wizard, I'm going to select Calendar. Here I can provide a name for the page that I'm going to create and select a table. So I'm going to use the demo calendar table for this and click on Next. Here you can map the columns from the table to the calendar attributes. So for display column, I'm going to select task name. Start date is already selected, and for end date, I'm going to select the end date column. I also want to show the time, so I'm going to select show time. So with this, the week and day views are also enabled in the calendar. And I click on Create Page. Now the calendar page is created. Let us see how this looks in the runtime. This is the calendar that the page creation wizard created. Because we selected show time, we also have week and day available as views. Using the list view, you can see all the tasks available in this, and you can also click on today to see the tasks scheduled for today. Now let us go to the page designer and see different attributes available for this calendar region. Under attributes, you can see various options available. You can see the display column, start date column, and end date column, which we mapped during the page creation process. I can also map the primary key column from the table. and I can toggle different views that should be available for the user. And using drag and drop option, I can enable drag and drop of events. So once I enable drag and drop, I get another attribute called drag and drop PLSQL code. Here I can define what should happen on the server when user drags an event from one calendar date to another calendar date. I'm going to use this PLSQL code to update the start date and end date of the task that has been dragged and dropped into a new date in the calendar. The new start date is available via the apex $new underscore start date bind variable, and the new end date of this task is available via the apex $new underscore end underscore date. The primary key value of the task is available via the apex $peak underscore value bind variable. With this defined, we can go back to the calendar region and refresh it. Now, when I move this particular task from 5th to 6th, this automatically updates the backend table because of the PLSQL code we have written in the drag and drop PLSQL code attribute. This is how you can create and customize the calendar region and enable drag and drop feature of this calendar region. To summarize, in this lesson, you have learned about the calendar region type in Apex. You have learned how to display event-related data using the calendar region type in your Apex application. You have also learned how to implement drag and drop functionality in the calendar region. Hope you have learned something new. Thank you for watching. Welcome to this module on adding additional pages to your application. In this lesson about creating, customizing, and using trees, you will learn how to display hierarchical data in your Apex applications using the trees component. Using trees region type in Apex, you can display the data in a hierarchical fashion. Trees are implemented using a single hierarchical query that identifies the row to be used as the start of the query and the relationship between rows and child rows of the hierarchy. Let us see how to create a tree on top of employees table. So I'm going to use the create page wizard to do that. So when I click on create page, here I have all the options to create different types of pages. If I scroll down, I have an option called tree, which can be used to create trees in Apex. So when I click on that, I will be prompted to enter a name for the page. I'm going to call it employee hierarchy, and I'm going to give the employees table here for the table name and click on next. Here, because I've selected create tree, it asks me to map the tree attributes with the corresponding columns from the table which I selected earlier. This is the employees table. So for ID, I'm going to map the employee number. Parent ID will be manager. The node text, I want to show the employee name, and it should start with manager, where manager is null. This is how you can map the tree attributes, so which in turn translates to hierarchical SQL query. I am also including both collapse all and expand all buttons. Now when I click on create page, this creates a page for me. Before jumping into what it has created inside this page, let us see the output. As I sign in, so this is the hierarchical tree that we have created using the create page wizard on top of employees table. So I can expand and see different employees and their managers. I can use the collapse all button to collapse all the nodes in the tree and expand all button to expand all the nodes in the tree. This is how you can create a basic tree in Apex. Now let's go back to the page designer and see what the page creation wizard has done out of the box. Here, as you can see, the create page wizard has created a tree region out of the box. And if I scroll down under source, if I expand the source, here is a SQL query that is driving the data for this tree. This is a typical hierarchical SQL query. Now, if I go to attributes, here you can see the columns from the SQL query are mapped to corresponding tree attributes. For example, the title column from the SQL query is mapped to the node label column. The value column is mapped to the node value column. The hierarchy is selected as not computed because the tree data, which is the region source, already has the hierarchy defined. But if you only give the table name in the source query, and if you want Apex to compute the hierarchy, Then you can select computed with SQL and then map the corresponding node ID column and the parent key column. Now let's go with not computed. The status column is mapped with the node status column attribute of the tree. This column will have values 0 and 1, 0 for leaf nodes and 1 for the nodes having children. And the hierarchical level column will be the level column from the SQL query. And if you scroll down, you can also define whether the node should be activated with a single click or a double click. And you can also define a tooltip. You can give an HTML expression or a database column as the tooltip. So if I select database column, I can select the title as the tooltip column. Or if I save this and go back to the tree, employee name is being shown as the tooltip. You can also provide HTML expression as a tooltip where you can write complex HTML expression to show the tooltip. Now let's keep it none. And if I scroll down, the link column is mapped with the corresponding link column in the SQL query. We also have the icon column. If you want to show specific icons to each of these nodes in the tree, you can specify the icon class in the SQL query, and the corresponding column can be mapped here to this attribute. The default icon CSS class will be the default icon if the icon column in the SQL query is null. Using the selected node page item, you can save the state of a tree. So when a page is being rendered, Apex looks into the session state value of the page item you store here. And if that page item has a value, which will basically be the primary key ID of a tree node, in this case, it will be the employee number. So if Apex finds a value in this page item, that particular tree node corresponding to the primary key value in this page item will be automatically highlighted. So using selected node page item, this is how you can save the state of a tree across page loads. Now, what I want to do is when user clicks on a particular node in the tree, I want to show the information related to this employee in a modal dialog. To do that, let me go to Page Designer, and I'm going to make use of the link column that we have here. So let me go back to SQL query. Currently the link column is now null. Before we configure the link, let me first create the modal dialog page. To do that, I'm going to go to Create Page Wizard. I'm going to create a form page and call it Employee Details. And I want to open this page as a drawer. So I'm going to select drawer here. And the table will be EMP table. The primary key column is already mapped. And now the form page is created. Going back to the tree region to configure this in the link column, I'm going to select the SQL query, and instead of null, I have to provide link to page number 3 and pass the employee ID. For that, I'm going to use apex_page.getURL PLSQL API to generate the link to page number 3. This defined, if I close and run the page, when I click on a particular employee, the employee details dialog opens showing the selected employee details. I can select a different employee and the corresponding employee details are filled. So this is how you can provide links to the nodes in a tree and navigate to different pages in your Apex applications. To summarize, in this lesson, you have learned about the trees component and how to display hierarchical data using trees in Apex. You have also learned how to use the link attribute of trees region to navigate to a modal dialog and display data corresponding to a selected node in the tree. Welcome to this module on adding additional pages to your application. In this lesson about creating, customizing, and using maps, you will learn how to display spatial data in your Apex application using Maps region. Let's get started. Oracle Apex has a region type called Maps, using which you can Visualize location data, real coordinates that are available in a database table in your Apex application. The map region is free to use, just like any other built-in region types you have in Apex. Using maps region, the developer can show a world map on a page and can add one or more layers or data points on top of this map. These data points can be coming from a table in your database or through a SQL query, using which you can show features on this map. The background map is a static map and it is coming from the Oracle eLocation services, and these background maps are ready to use and do not require any API keys. Maps also support a rich set of built-in marker icons and shapes. This is how a typical map looks like in Apex. Let us see how to create a map which shows small airports and large airports located in United States. Let us see how to create a maps region in Apex. I'm in this application called Maps Demo, and I'm going to go to Create Page Wizard. Here, I get an option to choose map as the component that I want to create. I can provide a name. For the table, I'm going to select the sample map airport table and click on Next. Since we selected map, in the next step, we are asked to map the geometry column and the tool table if required. For geometry column, I'm going to select the STO geometry column type which we have in this table. Alternatively, if your table has latitude and longitude stored in two different columns, you can select two numeric columns and select corresponding longitude and latitude columns. I'm going to go with the geometry column because this table has the STO geometry column available. For tooltip, I would like to show the airport name. If you want to add Faceted search on top of this map, you can toggle this, which would create a Faceted search. We'll see that in a while. For now, I'm not going to add Faceted search. I can also select which map style I want for this particular map component. I can select either points or lines, polygon, heat map, or extruded polygons. With these map attributes configured and the map style selected, click on Create Page. Now the map is created. Let's look at how this looks in the runtime. Since we selected points map style, these are all the points that we are getting from the database table sample map airports. Now let us see what the page creation wizard has created for us out of the box and how we can customize that in the page designer. If we go to page designer, here you can see there is a region that is created called airports and the region type is map. And if you look at layers, here there is one layer created called airports, and if you go to that, here you can see the name of the layer is airport and the layer type is points. That's what we selected as map style, and the source is a table or view and the table name is filled here. Now if you want to add more layers or modify the existing layers, you can do that from here. Now what I want to do is, for this demo, I want to create two different layers to show small airports and large airports visually different on the map. For that, I'm going to change this layer name to large airports and I'm going to give a SQL query here instead of a table. Now I'm going to modify this query a little bit. And here what I did, I added a where condition to only filter large airports based on commercial operations. If the commercial operations are greater than 100K, that airport is categorized as large airports and that will be shown as a different layer in this map. I have also formatted the commercial ops, air taxi ops and activation date with this SQL query defined. Click on OK. If you scroll down, we can see more attributes for this layer. I can map primary key column, which will be ID. And since this is large airports, I want to show this point objects slightly bigger. So I'm going to increase the scale to 2 and I can also add a color. I can choose the color from the color picker. And I can also choose stroke color. I'm going to select white. And I can also define a stroke width as 2. With these attributes defined, let us see how the large airports are displayed on the map as a layer. You can see these are all the large airports being displayed on the map. Now I also want to show the smaller airports. To do that, I'm going to add a new layer. To add a new layer, I click on the layers and click on create layer. I'm going to name this small airport, and for source I'm going to go with SQL query again, and I'm going to use the SQL query. This is the same SQL query as the previous one which we used in large airports. The only difference is in the where condition. Now the commercial ops between 0 to 100k are being classified as small airports. Also, I have added two more columns called marker type and marker color. If the airport type is heliport, then I want the marker type to be heliport, else small airport. For marker color, again, if the airport type is heliport, I am adding a color, else I'm adding a different color. With these defined, I can click on OK. This defined, I can scroll down to column mapping. The geometry column data type is SDO geometry because we already have a geometry column as we saw earlier. And for geometry column, I'm going to select the geometry column from the SQL query, and primary key will be ID. And for the geometry shape, instead of default, I'm going to substitute the column marker type which we defined in the SQL query with ampersand dot substitution. And for fill color, again I'm going to substitute the color from the SQL query using ampersand dot substitution. And I'm going to name this layer. With these attributes defined, let us see how this small airports layer is displayed on the map. This looks very clumsy and we can't see all the data points clearly. Let us fix this. To fix this, I'm going to go to Page Designer and select the airports region and go to attributes. Here I can define initial position and zoom. So by default it is set to based on spatial results. Based on the spatial results returned by the SQL query, the initial positioning and zoom of the map are defined. I'm going to change this to static values. You can also use SQL query to define the initial map position. I'm going to go with static values and select -90 for longitude and 35 for latitude. And I want the initial zoom level to be 3 so that the map is zoomed and I can see all the data points clearly. This defined, I can save and go back to my map, log out and log in to see the new initial map position in action. Go to the airports page. Now you can see the map zoomed into US and all the airports clearly visible because of the zoom level. But if you remember, in the SQL query, we have defined marker type for small airports as heliport and small airport, but you don't see them in the map. That's because these two marker types are not supported out of the box. So if we go to the shape attribute and go to help, you can see what are available options for shape attribute. As long as you use these attributes, you don't have to do anything. The shape renders correctly. But since we are using custom marker types, you will have to define them. To define them, you need to go to airports region and go to attributes. And if you scroll down, here you find under advanced property group, you find a property called custom SVG styles. So if you click on that, here in the help section, an example is provided to show you how you can define your own custom SVG styles. I already have them prepared, so I'm going to copy and paste them here. So here we are defining two SVG styles. One is small airport and the other one is heliport. These are the same SVG styles being referenced in the SQL query. This defined, can save and run the map again. Now you can see the heliport and small airports being displayed in the map. So this is how you can create a maps region and customize that maps region using the region attributes available in Oracle Apex. We can also add faceted search on top of a map, using which you can filter the data in the map based on the filter criteria applied by the user using the facets. Now let us see how to add a faceted search on this maps region. Let me go to Page Designer. Before I start with creating a faceted search on this maps region, the faceted region requires that the source of the maps region should be defined at the region level. So in this particular map, we have defined the source at the layer level. First, let us change that. So I'm going to go to airports, and under source, I'm going to select local database, and I'm going to go with SQL query. And for the SQL query, I'm going to use this SQL query which I already have created. This is the same SQL query as we used for small airports. It has the marker type and marker color defined, and the other columns required for large airports layer as well. I have added an additional column called airport category, where I define which airport should be categorized as small airport and which airport should be categorized as large airports. With this defined, I can save this at the region level. Now I can go back to my layers and change the source to use the region source. And for row assignment, I can select the new column which I added called airport category. And for large airports, its value will be large underscore airport. And for a small airport, I'll do the same thing, change it to region source. And for row assignment, select the new column and the value will be small airport. Now that we have moved the region source from layers to the region level, we can go ahead and create a faceted search region. To do that, I'm going to right click on body and click on create region. Drag this up and I'm going to name it search. Type will be faceted search, and the filtered region will be the maps region, which is airports. And for facets, we only have search here, which gives you a search bar, but I also want to search the airports based on state. So for that, I'm going to create a new facet and I'm going to give this state name. And for list of values, I'm going to use distinct values of all the values in the database column state name. This is already mapped, and this state name is a column in the region source. With this defined, I can make some UI changes. I want the airports region and the search region to be in a single row side by side. So I'm going to go to airports region and toggle start new row. And I don't want the airport region to occupy all the 6 column span, and so I'll reduce it to 3 and save. With this defined, let us see how this looks on the UI. Now you can see the faceted search region here and the maps region here. And when I select a state in the search region, the maps region is refreshed and the corresponding airports from the selected state are shown. You can select multiple states and the map region gets filtered automatically. So this is how you can add a faceted search on top of your maps region. To summarize, in this lesson, you have learned how to use maps region in Apex to display spatial data in your applications. You have also learned how to add a faceted search on top of a maps region to filter data in the maps region using facets. Hope you have learned something new. Thank you for watching.
Welcome to the Oracle Apex Developer Professional course. In this module on migrating applications between environments, I'll be talking about exporting applications. My name is Rupesh Tokala and I'm the product manager for Oracle Apex. Let's get started. In this lesson, you learn about Apex application migration, the steps involved in moving an application from one instance to another, creating a custom application, and exporting an application. Migrating application development between environments. An Apex application can readily be moved from one environment to another. It is a normal practice to move an application from development to test and into production. This generally involves exporting the application from development and importing it into test or production environment. Along with the application definition, you also need to export the underlying database objects and the seed data. So you need to create the DDL as well as the DML scripts. Migrating where you do your application development, for example from on-premise to the cloud, is much the same as the steps required for rolling out a new version of your application to test for production. Note that you cannot import an Apex application into an earlier release of Apex. For example, if you are exporting an application from a cloud instance that has Apex 22.2, you cannot import that application into an on-premises instance that is only running on Apex 22.1. You will need to update the target Apex environment prior to importing the application. You can check the version of Apex in both your current development environment and the environment you are migrating to. In any release of Apex, you can check the bottom right corner for the version information. Creating a custom application. Creating a custom application. From a developer's perspective, importing and installing an application is a complicated process. First, you create the target database objects and seed data. Second, you import and install the application definition and all related files, including images, themes, and any other required static files. Creating a custom application using the supporting objects utility greatly simplifies this process. Instead of performing numerous steps to create the database objects, and then importing and installing the application and all supporting files, you can define the supporting objects so that the application and supporting files can be migrated in a few easy steps. To install supporting objects, perform the following steps. In your workspace homepage, click the App Builder icon. I have Demo Projects application already available. Select the application and click Supporting Objects. The Supporting Objects page appears. Click Installation Scripts. Now click Create button. Identify the type of supporting object script you are creating. In this case, let us select Create from Database Object. Specify a value for name, and for object type, select one or more object types from the list. Let us select Table here and click Next. Now for table options, select Include DDL related to tables, and for objects, select the table names and move it to the right side. In this case, let's select EBA Demo IREMP table and Employees table. Move it to the right side, then click Next. Verify the scripts and click Create. On the scripts page, select Create Data Package in the task region on the right side of the page. Now specify a value for name data.sql and click Next. Now click Finish. An application written in Apex is stored as metadata in the Oracle database. As you define applications, pages, regions, items, and so forth, the definitions are saved in various tables defined within the Apex engine schema. When you export an application, a single SQL file is created by extracting the application definitions from the metadata tables. When importing the applications, records are inserted or updated if overwriting an existing application into the Apex metadata tables. Therefore, once an application is imported, all the application definitions can be reviewed from the application builder and the application can be run immediately. However, running the application will produce errors if the required database objects are not available in the workspace. To export application definition from your current development environment, perform the following steps. Navigate to the home page of your current application Click Export or Import, then select Export. Review the application details. This screen shows default selections for export preferences. You want to set export supporting object definitions to yes. You may want to set yes for export private reports and for export with original IDs. Exporting with the original IDs will allow an export from the target environment to be re-imported back into this current environment if necessary. Now click Export. You can save the exported file into your desired subdirectory. Your application definition is saved as .sql. It is a good practice to rename the export file and include a version or date so that the subsequent exports do not overwrite previous exports. You can also export your application as a zip archive containing separate files for each page and shared component and installation files specifically for the application export. If you want to export your application as zip, you need to split into multiple files to yes and click Export. In this lesson, you understood Apex application migration, you learned how to create a custom application, and then you learned how to export an application. I hope you learned something useful. Thank you for watching. Welcome to this module on migrating applications between environments. In this video, we will learn about importing applications to the target environments. Let's get started. In this lesson, you will learn how to import applications into your target environment. After exporting the application definition from the current development environment, you need to import the same into your target Apex environment. Perform the following steps to import an application. Log into your target Apex environment and navigate to the App Builder homepage. Now, in the App Builder homepage, click Import. In the Import wizard, you can either select a file or drag one here. Now click Drag and Drop. In your operating system's file browser, navigate to the subdirectory where you saved the export file. Locate the export file and double-click the file, or click the file and then click Open. For the file import confirmation step, click Next. File import confirmation is displayed. If you want to install the application, click Next. The screen shows the default selection in the wizard. For ease of reference, it is preferable to keep the same application ID in the target development environment. However, this may not be viable, in which case a new application ID will need to be used. For the install step, verify the parsing schema is correct and verify the build status is Run and Build application. Now, click Install application. You have installed the application in your target environment. You will need to install the supporting objects now. To do that, you need to set Install supporting objects to yes. Then click Next and then click Install. In this lesson, you learned how to import applications into your target environment. I hope you learned something useful. Thank you for watching. Welcome to this module on migrating applications between environments. In this video, we will learn how to migrate database objects. Let's get started. In this lesson, you will learn how to migrate database objects between different environments. The two primary ways to move database objects and data from one environment to another for a single application is using either Oracle SQL Developer or SQL Workshop in Apex. Oracle SQL Developer is a free integrated development environment that simplifies the development and management of Oracle database in traditional and cloud deployments. SQL Developer is familiar to most professional Oracle developers and DBS, but perhaps not to business developers. Oracle Apex includes SQL Workshop, which also provides capabilities for managing database objects. SQL Workshop is designed for application developers who do not have direct access to underlying Oracle database, such as in hosted environments like apex.oracle.com. This lesson covers how to migrate the database objects and data using Apex. The SQL workshop within Apex provides all the tools required for migrating database objects and data. Let us see an example where you generate DDL for database tables. You will use SQL workshop to create a script file for creating the table definition. In order to create a script file, perform the following steps. Log into your current Apex development environment, click SQL workshop, and then select Utilities. Now locate Generate DDL and click Generate DDL. Click Create Script. Verify whether the schema name is correct or not, and then click Next. For output, select Save as Script File and select the required object types from the list. Select any object types here that you wish to generate DDL for and that are needed in the target environment. In this example, for object type, select Table and click Next. Select the underlying database objects for your application and click Generate DDL. For script name, enter a meaningful name. Optionally, enter a description and then click Create Script. After a short wait, generally less than a minute, you will be returned to the SQL scripts page. The page shows a new script just created. Click the edit icon on the recently created script. Now click Download and save the DDL file to your directory. Now that you have exported the database objects and data from your current development environment, you are ready to load and create them into the target Apex environment. You can use SQL Workshop to load and run the script file for creating the table and trigger definition. Let us understand the steps involved to recreate the database tables in a target environment. You can perform the following steps. Log into your target Apex development environment, click SQL Workshop, and then select SQL scripts. Upload the script to create the tables first. Click Upload. For File, click Choose File. In the operating system's file browser, navigate to the subdirectory where you save the table script file. Locate the table script file and double-click the file or click the file and then click Open. Now click Upload. You can notice that the script file has been uploaded successfully. Now click the Run icon to the right of the script you uploaded. Click Run now. You can view the results in this page. You can also notice that the number of statements processed is 1 and number of statements successfully processed is 1. Make sure there are no errors. In this lesson, you learned how to migrate database objects between different environments. I hope you learned something useful. Thank you for watching. Welcome to this module on migrating applications between environments. In this video, we will learn how to migrate data. Let's get started. In this lesson, you will learn how to migrate data between different environments. You have exported and saved the underlying database objects of your application. Now, you need to export the data from your current development environment. In this demo, you will use SQL Workshop and Object Browser to download the CSV files for your data. Perform the following steps to download the CSV files. In your main Apex toolbar, click the SQL Workshop down arrow and select Object Browser. Select the table you want to download the data from and click Data. Now scroll down to the bottom of the page and click Download in the left side. Repeat the above steps until you unload data from all the application tables. The CSV files are downloaded to your local directory. You can also use SQL Workshop, Utilities and Data Workshop to unload the data in text or XML formats. In your target environment, currently the tables you have created do not have any data. Use the CSV files you downloaded from the source environment to populate the tables. The order in which the tables are populated is crucial to ensure referential integrity does not prevent data loading. To load data, perform the following steps. On your workspace homepage, click SQL Workshop and then select Utilities. Now click Data Workshop and click Load Data. You can either drag and drop or upload the file or copy and paste the data. In this example, let us select Choose File and select the file you downloaded earlier. In the Load Data dialog, for Load to, select Existing Table, click Table and select the table name in which you want to load the data. Note that you have already created this table in the target schema. Click Load Data. Data is now successfully loaded into the table. Repeat the steps above to load data into all the underlying tables of the application. Review the tables in SQL Workshop Object Browser to ensure the data has been loaded successfully in all the tables. In this lesson, you learn how to migrate data between different environments. I hope you learned something useful. Thank you for watching. Welcome to this module on migrating applications between environments. In this video, we will learn how to perform one-click remote application deployment. In this lesson, you will understand one-click remote application deployment, and then you will learn how to deploy applications to a remote environment using one-click remote application deployment. When developing with Oracle Apex, you can follow standard development lifecycle practices such as having different environments for development, QA or test, and production. These environments generally reside in separate database and can either be on-premises or use hosted services, such as the Oracle Autonomous Database Cloud Service or a combination of both. Oracle Apex enables you to export and import applications to and from the Oracle Autonomous Database Cloud Service, private and public clouds, on-premises, and even the free public evaluation service apex.oracle.com. Apex application export files can be imported into any other Oracle database, provided Apex, that release or higher, is installed in the target database. To deploy an application from one Apex instance to another, you must copy both the application definition and the underlying database objects used by the application. In Apex, you can package the app definition along with database objects, images, and seed data necessary for your application to run correctly by using the functionality in Apex called supporting objects. You can then export this app and deploy it into your target Oracle Apex instance, which will both install the application definition and create the underlying database objects. Oracle Apex simplifies this process by introducing the one-click remote application deployment wizard. Using a simple wizard, you can now directly export and deploy your application along with the supporting objects into the target system. You no longer need to separately export the application and its objects from the source system into files and then import them into the target system. With just one click, you can directly deploy your application definition along with the objects from the source system to the target system. For example, from within your development environment, you can deploy your application to the remote production environment. You do not need to directly access your production environment to import this application. Now let us see a demo on how to remotely deploy your applications. Configuring target environment. If you want to enable ORDS RESTful data services for your target schema, then perform the following steps. Navigate to SQL Workshop and select RESTful services. Now click Register Schema with ORDS. Review the ORDS schema attributes and click Save Schema Attributes. Now you can see a message that the schema has been successfully registered. Note that here you enable RESTful services in the target environment. Now you need to copy the base URL for the REST-enabled SQL service defined for your deployment server, Apex Prod in this example. In order to copy your base URL, you need to navigate to SQL Workshop, RESTful Services, expand RESTful services, go to modules and expand oracle.example.hr. Expand emp info and click get. Copy the full URL. Please copy and save this URL in your notepad. You will be using this later. Remotely deploying an application. In your development environment, Apex Dev in this example, navigate to your application homepage. Click Export or Import. Now select Remote Deployment and click Next. Choose an existing REST-enabled SQL service or create a new one. In this example, click the Add Deployment Server icon or plus icon next to the Deployment Server select list. Now in the Create REST-enabled SQL service, for name enter Apex Prod. For the endpoint URL, paste the base URL copied from the deployment instance. The base URL should include the ORDS context root and schema URL prefix. Now the base URL contains ORDS context root and schema URL prefix. Then click Next. If you have an existing credentials, you can select from the drop-down list. In this example, you will create new credentials. Oracle recommends always using empty credentials for remote application deployment in shared development environments. So only those with the knowledge of those credentials can deploy applications or run SQL. If the store credentials is turned off, the named credential will be created with null values stored as client ID and client secret. In essence, this allows you just to create the reference to the REST-enabled SQL without supplying credentials. Enter credentials for Apex Prod for credential name and turn off store credentials. Then click Create. Now you see a message that REST-enabled SQL service has been created. From the deployment server select list, choose the one we just created and enter the values for client ID and client secret. In this example, you used basic authentication. Therefore, enter the database username of your deployment schema for client ID and the corresponding password for client secret. Note that usernames for basic authentication are converted to uppercase. To include a case-sensitive username, prefix it with an exclamation mark. Now click Next. The Remote Deployment Options page appears. In the Deploy Application section, for as of, you can specify a time in minutes to export an app definition from an earlier state. This option enables you to go back in time in your application, perhaps to get back a deleted object. In this example, let us leave it blank. For export preferences, you include support object definitions in your export and ensure that they are installed into the deployment server automatically upon deployment. In this example, for export preferences and export supporting object definitions, select Yes and install on import automatically. For deployment overrides, in this example, even though the application does not exist on the target system, turn the override existing application option on so that you can preserve the application ID and enable this application for future overrides. After making the above selections, click Deploy. You can see the remote deployment successful message. Your application has been successfully deployed to a remote server, Apex Prod in this example. Now you can log into your remote Apex instance, ensure that the application is available and with the same application ID as in the source system. Navigate to the object browser and verify that the tables have been created and the data is available. Run the application to verify. In this lesson, you understood one-click remote application deployment, and then you learned how to deploy applications to a remote server using one-click remote application deployment. I hope you learned something useful. Thank you for watching.